Hello! Today I want to show you my favorite way of multiplying matrices with vectors and matrices with matrices. Let's start with an example. Let's say we have this matrix with 2 rows, 2 columns, and this vector, of course, with 2 rows and 1 column. And we want to multiply that. So normally the way it's defined and the way we learn it is like multiplying each row with every entry of the vector to get the entry, the first or one entry of the new vector. So I'll start, I multiply 1 with 6, 1 times 6 plus 2 times 5. 2 times 5. This is the way it's defined. The next entry of the vector then is 3 times 6 and 4 times 5. So it's like that. You take this row, multiply it with that column, and this gives you that entry, and for the next entry of the new vector you multiply this row again with this column. This gives you this entry. So we now have a look at this vector. We can see that this vector is equal to 1 times 6, 3 times 6 as a vector, plus another vector, the vector 2 times 5, 4 times 5. Because that's how vector addition is defined. And now what we can do else is we can get these numbers, the 5s and the 6, in front of the vectors, because that's how it's defined, how you multiply vectors with scalars. So the first vector is 6 times 1 and 3, and the second vector is 5 times 2 and 4. So we get this, and now we see that actually the first scalar is the first entry of our vector. The second scalar, 5, is the second entry of our vector. And these two vectors here are nothing else than the columns of our matrix. Yeah? The first vector is the first column, and the second vector, this is the second column. So actually we can multiply this in a different way, and this is the way I prefer, because in my opinion it's a little bit faster. You don't have to look too much. It's like that. I will write down the matrix multiplication again. Okay, what we do now is we take the first entry of this vector and write it here. And then we take the second entry of the vector and write it here. And now what we do is we take this whole column there, multiply it by 6, what's that there? So we can multiply 1 times 6, 1 times 6, 6 times 3, 3 times 6, and then we add the next column. It's 5 times 2, 5 times 2, and 5 times 4. In my opinion, that's much faster and exactly the same like here. And you can also multiply matrices with each other like with this method. The only thing you have to do is you have to update this vector you write down here. So I will show you that. Okay, again, we do nothing else that we look at each vector, that each column of the second matrix, and calculate the first or the second column of the new matrix exactly like in the way we would do it with the matrix and the vector. So we take the 5 and the 7 and write them here. So, and then we get the first column of our new matrix, 5 times 1, 5 times 3, plus 7 times 2, and 7 times 4. The next column of our new matrix is, we have to erase these numbers and take the second column, 6 and 8. I'll do that in the color. And now, for the second column of our new matrix, we multiply these columns with 6 and this column with 8, and we add them up. So it's 6 times 1, 6 times 3, plus 8 times 2, and 8 times 4. So this is our new matrix. I won't calculate it because I'm lazy, but that's exactly how you can calculate two matrices with each other. And I think, in my opinion, it's a very fast way, and I like it very much. Thank you for watching.